to finish this set of notes by today. So practice 5, we have a reduction. So in a reduction, our scale factor will be less than 1. So it becomes smaller. Okay, so every time you see this, just remind yourself. This tells us that scale factor less than 1. Because the image over the original less than 1. Image is smaller than original. Small over big, you get a fraction that is less than 1. We get all the information given. Now for part A, find the scale factor. In order to find the scale factor, I need to compare two lengths, two corresponding lengths. In the original diagram, I only have one length. So I have no choice but to use that, and I need to find the corresponding side. Therefore, in part A, instead of writing Kn over the corresponding side, remember your scale factor has to be the image first. The result, this is our image. Otherwise known as the result, this is the original. So you cannot put your original on top. You have to put the image on top. So in part A, scale factor. Okay, now this is equal to the image of our Kn. We need to find what that is. So Kn, its image is Ps. Ps over Kn. Okay, please do not assume that, without looking at the name, don't just assume that, okay, these two are corresponding side. You cannot just assume that. They didn't say it is a parallelogram, right? Maybe, for all you know, its corresponding side is over here. Maybe, right? Okay, so you need to check out the name also. Okay, let's continue. Now that we have this, Ps, 4.2 over 6.3, we will now get a fraction. How much is it? 2 over 3, huh? 2 over 3, yeah, I should have seen that. So this is the scale factor. Then, in order to find the value of KL, okay, KL, same thing, we're going to use what we have used earlier on. Form the two fractions, put them as equal. Okay, so KL divided by PQ equals to, then we're going to use whatever we have over here, Kn over, and then we already found that, hey, this is also corresponding. So Ps. Right, so now we are ready to substitute KL over PQ. PQ has a value of 2.6 equals to Kn 6.3 over 4.2. This over here, your 6.3 over 4.2 is now the reciprocal of your scale factor. It is the opposite of your scale factor. You know, it's 1 over your scale factor. So instead of 2 over 3 becomes 3 over 2. Okay, from here on you can just calculate to get the value of KL again. Therefore, KL is now 2.6 multiplied by 3 over 2. So 1.3 times 3, 3.9 cm. Alright, so put on your 3.9 cm over here. So this is one way to present it without explicitly using the scale factor. So if you want to apply what I covered yesterday, I think I wrote on the side, over here. If you want to use this, length of image equals to the scale factor times the original corresponding length. Okay, the result equals to the scale factor times the original. We can use this also, but you need to be very clear. Your KL, KL over here is your original. KL is your original. Therefore, we say that in part B, the alternative working is now like this. We want to find KL, so KL, we write PQ. PQ is equal to the scale factor. So the scale factor is 2 over 3. Okay, so this is the smaller one. Scale factor is equal to 2/3 of KL. This is by using the scale factor, the other way to do it. So since we want to find KL, then KL is now 3 over 2 times PQ. Right, it's just our algebraic manipulation. you divide by 2/3 on both sides, which is equivalent to 3/2. Then you just fill in the substitution, PQ is 2.6, and you get the same answer, 1.3 times 3, 3.9 cm. Same. Okay, so two different methods, up to you which you want to use. Okay, then now for part C. I'm just erasing because there's a lack of space. In part C, reflex QRS. QRS. Is this reflex QRS? Or is this reflex QRS? So we need to know the difference between acute, obtuse, and reflex. Okay, acute, basically you need to remember less than 90 degrees, between 90 and 180 degrees, as well as greater than 180 degrees. Okay, so we have 3 blanks over here. You are going to fill in our acute, reflex, obtuse. So which one goes where? Okay, first blank. The first blank less than 90 degrees. Less than 90 is the smallest one, the smallest angle. See, less than 90, then between 90 and 180, finally more than 180. So the smallest one is the very cute angle, very small and very cute. So acute over here. Then for the other two, reflex and obtuse, you have to find some way to remember them. Okay, so what I do to remember is that, hey, have you ever heard of a reflex angle triangle? Ever heard before? Reflex angle triangle? I don't think so. Have you heard of an obtuse angle triangle before? Obtuse angle triangle heard before? Should have lah. Okay, so then this doesn't work if you haven't heard of this obtuse angle triangle. So basically, triangles, they can look like this, or they can look like this. Okay, what is the difference between these two triangles? The difference is that in the first triangle, every single angle is less than 90 degrees. All of them are acute angles. Whereas in this triangle, I have one angle that is obtuse. This is more than 90. So because I remember there are two types of triangle. This on the right is called an obtuse angle triangle. Then this is that angle that must be obtuse. This is more than 90, less than 180. And then there's only one option left. More than 180 must be reflex. Just go and find some way to remember all of them, okay? So now they want reflex angle QRS. QRS. There are two of them. One is obtuse. The other is acute. Reflex. So the reflex angle is the larger angle. So in part C, reflex QRS. Angle QRS must be equal to reflex. Then follow the name QRS LMN. Oops. LMN. So let's search for LMN. Is it provided? LMN. Yes, it's provided. So the reflex angle LMN must be 360 minus 110, and you state your reason, which is angles at a point. Reasons are important. You're leaving us with 250 degrees. Okay, check that you have written your reason. I have no doubt that you are able to do this question. Just make sure your presentation is alright. So the next one, triangle ABC enlargement. Enlargement means scale factor greater than 1. Okay, so A, B, C, X, Y, Z. Okay, it is in order. There is no rotation involved over here. So find reflex Y, X, Z. Y, X, Z. Reflex angle Y, X, Z. Y, X, Z must be reflex. Y, X, Z, Y, X, Z, BAC, BAC, BAC. I want to find the reflex of this angle. This reflex angle. So this is going to be given by 360 minus, what is inside? 48 plus 38. Because I can't really, can't tell whether this is going to be more than or less than 90. So this over here is actually 94. So 360 minus this particular angle, we will write down 180 minus 48 minus 38. Okay, you know what I'm doing over here? Inside this bracket, we have our obtuse angle BAC. This is obtuse BAC. Okay, I'll just use some colors to help you. This portion refers to this. Alright, then I take 360 minus this yellow angle to result in the reflex angle. Okay, so put on the reasons. So I've used two reasons over here. One is the angles at a point. The other reason is angle sum of triangle. These are the two reasons that I used. So I found out that this is actually our 94 degrees. So 360 minus 94, we get 266 degrees. That is our reflex angle. Y, X, Z. 266 degrees. And then our part B, calculate ratio of ZX over CA. ZX, CA. Oh, I don't have the information. ZX, I don't know what that is. CA, I also don't know what that is. ZX over CA. Big question mark. But since I know that this is an ABC is the enlargement, this is the image. See, ABC is the enlargement, so this is the image. This is the original. Quite tricky over here. Original. Okay? Now, I know that both of them are similar. I try and find another pair of corresponding sides where I know the lengths. ZX is in our numerator. The smaller triangle is in our numerator. So I want to find a corresponding side that is available. If I were to choose 6, it is available to me, but I don't have the value over here. Then it becomes useless. How about if I try 4 and 10? Now it works. So put them down. ZX over CA is the same as YX over BA. And the ratio is given to be 4 over 10, which is 2 over 5. Alright? Now, question, my question to you, is this the scale factor? Is 2 over 5 the scale factor? I've got 1 over the other, isn't it? So the answer in this case is, no, it is not a scale factor. Why? Because I have in my numerator the original, the 4. Whereas the scale factor, I must have the image on top, the result on the numerator. So this is not a scale factor. This is the opposite. It is the reciprocal of the scale factor. It is the 1 over of the scale factor. So now to find the length of BC, again the same two methods, but since this case they didn't ask you to find the scale factor, I will not show you the second method. I'll show you our first and usual way of doing it. BC over here, find the corresponding side, which is YZ. Okay, BC, YZ, then use something that is available to you, BA over YX. Fill in the blanks, BC, YZ, we have 6, BA, that is 10 over 4. So BC, 5 over 2, which is, this is now our scale factor, times of 6. 15 cm. Any questions? Shini, okay? Then practice 7. Quadrilateral mapped. Okay, this is another term that we use for a transformation. We map the original to the image. Alright, now, again the naming is important, the sequence is important. So A, B, C, D, A, P, Q, R. Okay, they are corresponding. Find D, A, B. D, A, B. Okay, this is the angle that we want to find. Now, in order to find this angle, we see that this angle actually belongs to the small quadrilateral as well as the large quadrilateral. If I can find all the angles in a small quadrilateral, then I can find the resulting angle, which is just 360 minus all the other three angles. That's one way to do it. The other way is that if I can find this angle APQ, that large angle over there, that angle found in this large quadrilateral, then same strategy, 360 minus the rest. Okay, so two options for you. Clearly, it will be easier to use this angle because you only need to find one blue angle as compared to finding two green angles. Okay, so let's just find the blue angle now. Okay, so our angle APQ is the same as angle ABC, which is 122 degrees. And now we can find our angle DAB. DAB will be 360 minus our 122 minus 58 minus 62. And write down the reason before you compute. Angle sum of quadrilateral. Okay, so that I know where your 360 came from. You are telling me, hey, this is not angles at a point, huh? It is not angles at a point. I used angle sum of quadrilateral. Okay, so let's continue. 360, 122, 58, 62, 118 degrees. Yes. Interior angles, did they say they are parallelogram? Is a trapezium? No, right? They didn't say it's a trapezium. Therefore, you cannot talk about interior angles. But is the answer the same? Then it is a coincidence. So if it is a coincidence, can I give you the full marks? Cannot. So this is actually this could be a 3-mark question. Over here you get 1 mark. Over here 1 mark. Over here 1 mark. But because if you were to say that, hey, interior angles, therefore it is just 180 minus 122 to get, hey, oh wait, 180 minus 62 to get 118. Then you state interior angles, parallel lines. You get 0 for the meta mark. You get 0 for the final mark. So means you get nothing, 0 out of 3. Even though your final answer is correct. Because it's a coincidence. Okay? So be very careful. Reasons, you must be correct. If your reason is wrong, then exactly why we want to see your reasons. You know, whether there are any misconceptions. So now for the final question, practice 8. Triangle ABC, similar. ABC, similar to ADE. Okay, please put a star over here. They like to combine triangles like this. They love it. The people who are setting the test paper, they love to set these kind of questions. We combine them together. Because, so it's just like the previous one, there is a common angle over here. This particular angle belongs to both the small triangle and the large triangle. Then, we also need to understand the diagram properly. Okay, look. On the right side, we have our small, okay, let me highlight the small triangle. And then we have our big triangle. Okay, you can tell which are the corresponding sides. But the more tricky part is the corresponding length. So this 6 cm refers to AC. Whereas the 3 cm refers to CE. Now CE is only a part of the long triangle. So AE, this is our 9 cm. We have to be comparing our 6 cm with our 9 cm because these two are the corresponding lengths. Now with these two, I can tell that, okay, we can talk about the scale factor if we know which is the original, which is the image. But this time they didn't say anything about image or transformation. They just tell you that they are similar. So no scale factor to talk about. But we can have the ratio of the sides. Okay, it is in this case 2 to 3. 2 units to 3 units. For the small to the big triangle. With that in mind, I know that this ratio, this length to this length, must also be 2 to 3. Similarly, for, I think this 7.5 refers to AB. This 7.5 to the entire side over here is also 2:3. So subsequently, if they want me to find the value of dB, the length of dB, I will have to find this long length of AD, take away my 7.5. Alternatively, you view it as 2:3, so cut it into two parts, and this length same as this length. Get it? 2:3. So in the same way, remove everything. If I were to break down this 3 cm into two equal parts, then we have 2 units. Likewise, we have the same, this distance, 3 cm, is also this 3 cm, 2:3. Okay, likewise over here, 3 cm, 3 cm, this must also be 3 cm. So from the diagram, we can actually tell all the answers straight away. We can tell all the length. As long as you know the one ratio, good enough already. Okay, then besides that, one more thing. Since these two triangles are parallel, okay, this is something quite new. Since these two triangles are similar, this is a common angle, right? It belongs to both the small and the big triangle. Now, I want you to think carefully. Are these two angles the same? Are they the same? If these two triangles are similar. Okay, what is the reason that they are the same? Because they are similar, right? They are similar, that's why they are the same. Then, now comes the interesting part, which I suspect may be tested. Are you able to prove that these two are parallel lines? Question didn't say they are parallel, It didn't say. But are you able to prove that these two are parallel? Can or cannot? Do they have to be parallel? What do you think? Do they have to be parallel? Okay, so I see nodding heads. So yes, they must be parallel. If they are not parallel, you can't get a similar triangles. But how do you prove that they are parallel now? What does this look like to you? I have given you the clue already, these two angles over here. I drew in the parallel symbols, although we don't know yet. I don't know whether they are parallel yet. We need to prove it. So what does this remind you of? Corresponding angles, parallel lines. Does it look like corresponding angles, parallel lines to you? Yes, right, the letter F. But the corresponding parallel lines only can be used if I know that they are parallel lines. So our corresponding angles, parallel lines, works this way. You tell me that they are parallel, then I tell you that these two angles are the same. That's how it works. But this is the opposite. I tell you that these two angles are the same. Now you can conclude that they must be parallel. How? By the reverse. Okay, this word reverse, in mathematics, we're going to use the word converse. By the converse of corresponding angles, parallel lines, these two must be parallel, because these two angles are the same. Okay, I think we did something similar last year already. Alright, converse, but that wasn't tested here. If it is me, I will have a part C, prove that BC parallel D, BC parallel D. Then the presentation will be very crucial here. Okay? So since that wasn't asked, let's just go ahead and do our DE. Okay, so DE, part A presentation can be like this, DE over BC. DE over BC. So the big length over the smaller length. I need to find the another pair of corresponding sides with the lengths given. Now, AD is not a good choice. I don't know the length of AD. I don't know the length of BD. Let's take a look at AE instead. I don't know AE yet, but I know that AE is made of AC plus CE, which is 6 plus 3. So to be very, very clear in your presentation, this is what you can write. AE over AC. Then you continue to tell me that AE is actually made of AC plus CE over AC. Now I can fill in the blanks. DE, which is what we want, that's why we put it in the top left hand side of the fraction. BC has a value of 3. AC has a value of 6 plus CE value of 3. AC another 6. So 9 over 6. So therefore DE will be 3 times of 9 over 6. Which gives us 9 over 2. 9 over 2 is 4.5. Okay, 9 over 2 cm. 4.5 cm. Okay, does this make sense? Remember earlier on I wanted to cut this 3 cm into 2 parts. Right, then we will have 1.5, 1.5, and because the ratio is 2:3, so 1, 2, 3, 3 parts, 1.5 cm each. To give us our 4.5 cm. And then part B, BD, the length of BD. Okay, erase all this. Now BD is not one of the 3 lengths of any of the triangles. Do you see that? There are 2 triangles, right? Then each triangle has 3 sides. It has 3 lengths. This BD is not one of the lengths of the 3. It's not one of the 3 lengths of the 2 triangles. Right? It doesn't belong to the small triangle. Neither is it one of these 3 for the big triangle. Rather, it is a part of one side of the big triangle. Why am I emphasizing this? Because I'm trying to tell you that you cannot just write BD over something equals to something over something. Because there isn't a corresponding side to BD. Okay? BD doesn't have a corresponding side. Therefore, we have to write, I want a BD, right? BD is part of the length AD. I need to find AD first. AD over AB. Then keeping in mind, in my mind, I know that BD is inside. BD is inside my AD. If I can find my AD, I just need to remove 7.5 and then I get my BD already. Okay, so that's the plan. So AD, that is the longer triangle. Let's use AE in this case. AE over AC. So AD is actually broken up into AB plus BD. Okay, this part, this line you actually can skip it. Okay, just go and find your AD and then do your subtraction, it's fine. So AB 7.5 plus BD. AB we have another 7.5. AE which is 9 over 6. Then you just solve and get your answer for BD. Okay? So this next one is this homework question due tomorrow. Bring it. And then you have already received your 7.3 notes on map scales and calculation of area. So watch the video, go through the information in the provided in the QR codes.